Hey guys, figured I'd give a quick update with the self-sustaining system. Um, this isn't connected in any way. This is my future supercap pack that will. This is just for testing. This supercap pack will replace that battery. So basically, what I'm demonstrating is we have the system self-sustaining. It still builds up a charge. This is what's recharging our input. So what you're going to want to do is build the transmitter exactly as I describe in my PDF. Get yourself a large aluminum plate, plastic wrap it, and connect this aluminum plate that's insulated. You run a lead off the aluminum metal, you connect that to the negative of your transmitter, and it will save you a lot more power on the efficiency side, and your wireless power will enhance quite a bit. So anyway, what's occurring here is the super efficient transmitter wirelessly transmits power to the receiver. The receiver has these huge caps, 100 volt, 10,000 microfarad, and those rapidly recharge and dump into this battery. And watch how rapidly this battery will recharge when I shut the inverter off. And this inverter recharges the input source indefinitely. The gain in power is coming from the fact we're in resonance, and we have a huge insulated aluminum plate here, which is collecting more power. As you see, we are dropping in power because we're gaining charge. That's our power consumption on the inverter end. And again, this battery is just for experimentation. It will take, this battery will turn into this. So now I will shut the inverter off. We will watch how rapidly the high frequency from this receiver that's dumping into these caps recharge this battery. So watch this. The high frequency can recharge batteries super quick or super caps. Watch this. Inverter off. Watch how quickly we recharge now. This is just a 10 amp hour 12 volt AGM battery with big plates in it. So that's the advantage of using the high frequency. The fact we use high frequency, it gives us an advantage. We can rapidly recharge capacitors and then dump them into storage devices to run huge loads. So that's how that works. Nothing breaking the laws of physics about it. Simple scientific engineering. The transmitter is at a frequency of 3.6 megahertz now. And something interesting I noted is just connecting wires to your input supercaps can actually detune the system. Like keeping the DC supply that recharges the input that plugs into this inverter that runs off of this battery that's charged from the receiver actually slightly detunes it and makes our power transfer not that optimal, but as you see, we are recharging still because of the high frequency. That'll be at about 100% in maybe 5 minutes. This also isn't the best inverter for efficiency. And again, we still have all that wireless. This coil is just radiating power. You see we are charging. Here's our power consumption. Here's a tour of under the desk. The system is completely self-sustaining. We'll recharge the input again. And just connecting these wires slightly detunes the system, which is interesting. And then I'll shut that off once it goes to 3.5 amps. Technically, we are still charged because we're dropping in current. The system doesn't want to draw any more current. As you see, a full charge on this supercap bank is 13.8 volts, and we're dropping in current because the system is nearly fully charged because it's in resonance. So once that drops to 3.5 amps, I'll shut it off and disconnect it. The fact this light is green and not red because the system isn't drawing in power, we're almost at a full charge. We are drawing a little bit to run the transmitter, but here we go. Here's how we look here. We can fully sustain what we're driving. Just going to position this a little bit better. As you see, that actually charged up a little bit, and you get the tuning just right. You might even see that go up while the input is recharging. And again, this inverter does draw a lot of power just idle. Just having it on with no load draws a lot of power. Oh, and it did recharge a little bit while we're simultaneously recharging our input source. The key was those huge capacitors there around the receiver. And I think I'm a little too close to the receiver. I might be detuning it. I'm going to back up a bit, and the charge went up. The system is highly sensitive to tuning and just being near it. Alright, so our input is just about at a full charge again. As you see, our current keeps dropping. Once that hits 3.5, I'll disconnect. And I know just staring at meters gets boring, but this is the process. I'm showing you how it's self-sustaining. We're on 57 watts. And input is pretty much recharged. I'll be disconnecting very soon, and we will watch this rapidly recharge again. Okay, I'm disconnecting in 3, 2, 1. And now we will rapidly recharge due to the high frequency. So what's occurring is our supercaps want to charge up to 100 volts DC. They're electrolytics, big DC caps, and they want to charge to 100 volts DC, and they're really fighting the VI curve of that battery. So that's in the high frequency of the Scotty diodes there that are switching, allow us to recharge the supercaps very quick. I mean, not the supercaps, those are just regular caps, big DC caps. Not sure if you can hear the system, but it is making a tingling sound. Oh yeah, and it will charge even quicker if I disconnect again that DC wire that just goes from the inverter to the DC supply, which then just plugs into the input supercaps. And just touching any component near here will give you a shock. So I'll disconnect this. And like I said, just touching any component near here will give you a shock. And I can feel it buzzing in my hands when even being near it. And we are recharging very fast. So again, that's the system. We'll take a look all around it. That's just my shotgun that lives in the corner. Ignore that. I have way too much shit in my room. Just gonna grab one of those little wireless lights. Wherever it is, I think it's down here. I don't even know where it went. I have like $5 grand worth of shit in my tiny room. Alright, here we go. So our charge is at 72%. As you see, the RF is everywhere. This is what was shocking me. Just touching any part of the system will shock you. You can even hear that ringing. So yeah, I'm showing you the remarkable effects of the system, how it can be self-sustaining, how the high frequency rapidly recharges a DC battery or a supercap bank that can then run an inverter to run huge household loads or keep the system self-sustaining. And once this hits almost 80%, I'll turn it on again and we'll watch the system self-sustain itself again. This might be a long video. And I can run virtually anything here. And I can also add another ground extraction circuit at a distance. Or even another receiver coil. Turn it to pure DC. And add it to that super receiver coil for even more power. %. Oops, 75 there. We jumped a bit. I think it's because I really got to get a grounded metal bar for tuning and run along the coil like this. That would be optimal. And this inverter is giving off RF too, just by being near the system. As you see, look at this. The RF is just nuts. Like, oh my god. If I make good contact, that will get blindingly bright. And like burn my hand. Yeah, that's burning. And that actually increased our charge. And here's where it gets weird. Look at this. See what I mean when that RF is everywhere? Even in the inverter? Every part of the system is in resonance. Every single part is resonant. Even my freaking DC power supply that recharges the input. Every part of that system is in resonance. I'd like to see any major inventor replicate this, or electrical researcher. This thing will blow them out of the water. My challenge to everyone is to replicate this perfectly. And I didn't even hook these up yet, and there's still radiant energy in them. Still recharging. We're higher than when we started. So again, get this out of the way. I'll reconnect my DC power supply here. Turn the inverter on. And we will watch it recharge the input again. Here we go. And very soon we will draw less current because we're still in a resonant state, drawing minimal power. And again, once that hits 3.5, I will disconnect. As you see, it's dropping current rapidly because we're still carrying that charge from last time. In case you doubt where the cord goes, around 70 watts, and this super receiver is what's sustaining the system. Actually recharging because the super cap bank there, the huge DC cap bank, is fighting the VI curve drain of the battery, which is funny. That runs the inverter. So this is a self-sustaining system with 300 watts of green power to use. And this video will be long to document how the system is fully self-sustaining. Forgive me, I have bad allergies. Could you imagine if I had another one there of those caps? I'm going to make a whole bank of these. And you gotta be careful with those. If those short out, it's dangerous. It'll make you go deaf. See if we can tune it a little more. It's kind of, and it's also kind of, if we didn't have this receiver coil hooked up with those mega caps, It'd be kind of hard to sustain that much of a load from just this little thing. This little DC battery. We can see it right here. Mighty Max battery, 12 volt, 10 amp hour. Ooh, that's giving me a shock. System's in a pretty stable state. Still maintain impressive wireless. Even in strange parts of the system, even the wood is emitting wireless. Even the wood. Even my wood has become conductive. That is weird. It's really focused near the inverter. And me just standing here somehow increases the charge. And we're actually overcharging the input now. I'm gonna have to disconnect this. The input's almost overcharged. What did I do? Yeah, I shut the inverter off first. Let me rapidly recharge. Kind of recharges in chunks. And I'll disconnect this and this because it slightly detunes the system. And there we go. And the funny thing is, in fact, even just having anything plugged into the inverter detunes the system. I'll just leave this right here. And look at that, it's already going up. Oh yeah, look how much quicker that is now. Just having lengths of wire near the plate can cause detuning. And you can tell it's in resonance when you get that tingling sound. So I'll let that charge up till 76%, and then we'll do a voltage reading on our input caps. So that's just going, charging away happy. We still have all this radiant power. Can do a lot more than light up LEDs now. And that circuit is so modified, it's almost not even a Slayer exciter circuit anymore that's driving it. Still maintain all the impressive radiant energy effects, even at distance. These are just old schematics I was going through. as that. Touch to anything metal. This will light up. This will light up to 500 feet away. So as you see, the refinement to the system is I made one super receiver coil and one super ground extraction circuit that accumulates power. Those two are combined, and we have extremely impressive power. And I said I was going to let that charge till 76%. So, I'm going to just take a tour around my messy workshop / room. See, there's nothing under the desk anywhere. That's my trash can. That's my recliner where I come home from work, sit in it, put my feet up and relax. I also got this cool book. Very handy. Shows some pretty cool stuff. Has good stuff on capacitor discharge timing circuits too. Where exactly did it show it? I think it was towards the beginning. But pretty good book. I think that's it. Yeah, right there. Capacitor discharge circuitry. So that's that. This is what the book looks like. See what our charge is at. Almost at 70%. Interesting, our input dropped a little bit. That's our input power consumption. And to sum it up, supercap bank runs 0 to 120 volt DC to DC boost converter. Powers up the transmitter, gives us fine control and tuning over it. We can tune the voltage and the current. Transmitter wirelessly powers up this super receiver, and the high frequency of this super receiver goes through a full bridge rectifier made out of new Scotty diodes. I think they're SS560, and it rapidly recharges that cap bank, which then dumps into this battery, which then can run an inverter and self-sustain itself. And the ground extraction circuitry, that's also combined with the receiver coil too, the DC of it. If you were to accidentally short that out, it's ugly. Like, you don't want to do it. It's frightening. 71%. When we hit 76, I'll have the system recharge itself again. And again, here's under my desk. There's no hidden wires anywhere. Hopefully you can see in there. In fact, I'll even move this because we're not using it, and that's shocking me. So I'll just set this guy aside somewhere for now. %. See if we can reposition things a little better here. I think we're good. Just waiting for that to hit 76%. And light, any intense light source hitting the plate will also add power to the system. And that could be an artificial light source or the sun. In fact, let's see if UV light hitting the plate recharges it quicker. I'm going to shut my room light off. It's kind of a diary series of the system. As you see, the light hitting the plate actually enhances the charge that's occurring. Even made the system a little more efficient, drawing a little less power. Add another UV tube. Seems to really like UV tubing. We're almost at 73. Oh, there we go. I'm going to push this system hard tonight and show you guys everything it can do. So this video will completely silence the skeptics, the haters. I don't know if it'll silence everyone, but it'll certainly make them think, get them thinking. And this big tube is actually slightly detuning things. I can hear it. Now it isn't. Now it's not detuning anything. You can tell by the sound. We're at 73. Move this just a little further away. So not only do we have all these fluorescent tubes lit wirelessly, we're recharging a DC battery very rapidly with the high frequency of the receiver coil to run an inverter, which then powers huge loads. We're doing all that, and we still have wireless power at distance on my bureau here. I'll show you something else cool that I was working with, but I gotta turn my light on for a second. Alright, so I was thinking of making a type of tube device where like glow powder is painted on it, because this is glow powder. And because watch how, because the wireless UV light is so efficient, then it activates that glow powder. And would that be able to like store a charge up a solar panel and then charge a cap bank slowly that way. That was just an idea. Because look at how efficiently and quickly this charges the green glow powder. And that's bright. This is the world's brightest glow powder, supposedly, and longest lasting. So that was an idea, to make some type of like light amplification tube with solar panels on it and glow powder, and the light would light from the wireless field. So at 73 right now. Turn my light back on. Get these big tubes out of the way. We get the idea. The system is insane. It's got nearly no limit to it. The mine's the limit. Not sure if I can keep recording much longer. My phone's gonna run out of space soon. We're at 74. And the moment that hits 76, I will reconnect the system, recharge the input, and take a power reading on it. For those who want a close-up of the transmitter, here it is. Almost 76%. It's getting kind of, I know this might be kind of like a boring video, but it's to document everything and show how the system, what it can do. The only thing I would like to save a little more power is if I could dim the LCD screen on this thing, because it does draw 60 milliamps just idle. Almost at 76. I'm running out of space on my phone. You might have to charge this thing early. Ooh, 76. Alright, I saw it say 76. So I'm gonna hook the DC power supply back up. Just don't want it touching the metal plate and screw things up. Ouch. Everything is shocking me. 76. Okay. We will now hook it back up to have the input get recharged, and then I will shut the system off and we will take voltage readings on it. Jesus Christ, I can't pick this wire up. There we go. Everything's always knotted. Alright, here we go. Ready? activating. And we will see how this will recharge pretty quick because it's in a resonant state. It'll stop drawing power pretty soon. It'll turn green any moment. There we go. And this also isn't a very efficient power supply. The only challenge I'm trying to overcome is when I connect my inverter to recharge the input, there's a slight detuning, which causes the receiver coil to get a little weaker in power output. And that's why disconnecting it after recharge solves that problem. So, still a few bugs to work out, but it's mostly there. It's very impressive and is self-sustaining. Drawing some power. Again, once that hits 3.5, I'll shut it off. Interesting to note, it says our energy is still full somehow on the inverter. So our high frequency cap dumping here is recharging this battery. And this battery isn't really the right thing to use. I should be using a supercap here, but this is just for experimentation to see if you can use a regular deep cycle AGM battery, and it seems like you can. It's a little slower as opposed to a supercap, but it does work. As you see, we're drawing even less current because we were nearly fully charged. This thing's actually slowly recharging now. Sometimes it acts funny and we'll experience boosts in power. I wonder if the UV tube near the plate will cause it to get a boost in power. Doesn't seem to be helping. Almost at 3.5. I don't know, it gets boring just staring at meters. And we're really pushing this little battery with a lot of rapid recharge cycles and discharge, recharge and discharge. That's why the supercap comes in handy, or the latest battery tech. It can keep up with the rapid charge and discharge cycles. And to end this video, I will show you what those caps on that receiver can do. Alright, that's just about good. We'll switch you off. Rapidly recharges. I'll give that maybe a couple minutes to get a bit of a charge, then I'll disconnect. Although I can't wait too long because I'm running out of space on my phone. Alright, let's disconnect this then. And as you see, just having the leads from the DC power supply touching the input caps that run the system detune it somehow, and it draws more power, like 24 watts. Just connecting the leads causes it to draw more power, which is weird. It's like a detuning effect. So here's our charge here. It's probably good enough. I'll shut it off. We'll do a voltage reading. That's the charge on that battery now, after everything we just did. System is off. So here's our charge. 13.25. Of course the fucking wire's in the way. Why wouldn't it be in the way? As you see, we're pretty much at a full charge. And now I will show you what this circuit can do. I'll remove the inverter. Okay, the inverter is removed. Next, this is the output, and I'll remove our little battery buddy here. That's at a 53% charge. I'll disconnect the meter that's here. Take a look at them. There's nothing funny about it. Now I will show you the output. I can't do an amp reading on this anymore because it'll blow the meter. But I will show you what this thing can do. So I'll turn it on, the system. And this DC cap bank, I'm showing you what the receiver coil is doing to that battery that then runs the inverter and runs everything, the load. So this is what this receiver coil does now. Look how bright that gets. We're consuming 25 watts. And I'm going to do a 40 watt pulse. Better yet, I'll even screw in 200 watt light and show you the power of the capacitor pulses in the system. Ooh, I just saved that from breaking. This is where it gets scary, like you have to be careful and respect the system now. You see that? We're only consuming 25 watts. And we're pulse discharging 200 watts to run this bulb from our super receiver coil. That's the power of cap dump circuits. And the high frequency, the fact we're at 3.6 megahertz, the high frequency rapidly recharges the caps through the Scotty diodes. And as you see, if I were to just leave this connected directly, it would run and then lose its charge and dim out. But running that has no effect on our input that runs the transmitter. So again, I'll show that. After about 10 seconds, I'll connect it. Okay. So I'm showing you how we can do 200 watt pulses of power from a 25 watt input wirelessly. Again, I'll shut the system off. Oh, what I want to show you too is I'll let it charge up. And I'll show you how when I shut the system off, you have to then discharge those caps, or you'll be in a lot of pain if you accidentally touch them. So yeah, that's that. Hope I explained everything pretty well. Showed you what the system could do. We ended with a charge of, on this battery, and this thing has been subject to so many radiant energy pulses it sometimes charges itself very slowly. So yeah, that's that. This has been a video documentation of the system. Here's inside of this thing. There's nothing funny going on. That's how it looks. See underneath it. Hopefully you got a good view of that. This transmitter. It all just breaks down into basic pieces. And yeah, good day everybody. Stay tuned and stay creative.